Hello, welcome to Handmade Hero, the show that codes a complete PNG reader live on stream because we wanted to add a PNG reader to our game for live art asset updating. And we've written almost all the code. We have not written the fixed Huffman table version. We do not actually have any files at the moment that use the fixed Huffman table version. So we don't actually know. Maybe we'll never actually do that. I don't know. It could turn out to be that we don't ever actually get any files that have that. And this is only for our files, so we don't really need to. So we've written all of the code for a PNG decompressor, including the transforms, which we wrote yesterday, but we are not quite correct yet. We have a bug or multiple bugs in the code that we now have to debug in order to get proper PNG images out the other end. That is all we're doing today. So we're just going to look at that code and figure out what's wrong with it. Now, if you remember correctly, we're sort of going in phases. Right now, we have not really looked very carefully at trying to make sure that our output is correct. We sort of cursorily inspected it, but we haven't really taken the time to test to make sure it's exactly right. And so that's something we might do a little later on. Right now what we're doing is trying to figure out how to make sure our decompressor produces consistent output. What I mean by that is that it should always produce an image of the size that we were told that we had. And the reason that this is a difficult problem is because if you think about what happens with a Huffman encoder or other kinds of things like that, like are in play with PNG, compressed file formats and the like, any little bug that you have in interpreting how many times to replicate a symbol or what the particular symbol code should be or any of those sorts of things, they will lead to you misinterpreting the data stream, which will lead to producing too much or too little data. And so what we will find when we debug this situation, for example, is that something we have done incorrectly in how we are handling the data stream is causing us to produce, say, too much information, or it's causing us to try to, because remember, this is a dictionary compressor, so we read from our output to produce new output. So we read from both the input and the output. When we have lookbacks, we may, if we misinterpret the lookbacks, we will jump too far backwards. All of those sorts of things, they're very tweaky and very finicky. You can get just one little bit wrong, and you can still decode several images perhaps, but when you get a particular image that has some aspect to it that hits upon the thing that you've done incorrectly, that case will lead you to produce too much, too little data, read outside the image, whatever. So what we're trying to do right now is get our system to the point where we don't do that anymore. That doesn't mean we're producing the right images. We could still have bugs that are unrelated to properly decompressing the literal bit stream. But right now what we're trying to do is get to that point. So we want our Huffman decoder to always produce the right number of bytes when we get an input stream from a PNG. So what we want to do today is to start working towards that. And we're not that far, but even though I think we're not very far from a working PNG compressor, this is hard debugging. This is the kind of debugging that's difficult because we didn't write the file format. We're just going based off what we think we understand from the spec, which we don't actually know that we do, right? And so we're constantly not sure exactly what we should or shouldn't see in any particular place. That makes debugging difficult. Now, I will also point out the fact that if you had to write your own PNG reader at home for some reason, and it was not about a programming exercise, a perfectly reasonable thing to do is to look at someone else's PNG reader, run that PNG reader to the same point in the output as yours, see if your output matches. This can help you figure out where you've gone wrong. So having a working version can be a very valuable way to debug something. I don't want to do that because I want to show you the process, and this is why I've done it this way so far, the process of going from just a spec. Because if you are someone who programs new stuff, does engine programming, that sort of stuff for a living, you will often come into circumstances where you do not have working versions of something that you need to load. So I don't mean to imply that you shouldn't do that. You should. It's a useful technique. It's just I'm trying to show at this point how to debug or what the process looks like when you're trying to bug something where you don't have the luxury of just being able to go and look for someone else's code. Same with Handmade, how on Handmade here, we will often rewrite something. Maybe we could have gone and gotten code to do, for example, something that was in an STB library. Again, the reason for that is because this is educational. We're supposed to be showing how to do these things because you don't always have one available if you are a programmer who's, pushing the boundaries, working on a new engine, working on things that people haven't done before. You don't have the luxury of going to Stack Exchange and posting a stupid question. So let's go ahead and finish with that. This is the broken file. And just to refresh your memory, when we run it, what we see when we get to this point, you can see that we have our two pointers here, right? We've got the source that we're supposed to be repping from. We have the dest that we are writing to. And when we look at these two, what we see here actually is that the source is not actually off the end yet. So you can kind of see here, I don't know if this will let me do this. Oops, I did that wrong. That's what I wanted. What you can see here is that the source technically, this line will not crash the source. The source technically is still readable, it looks like here, right? Because the very specific one it is reading is actually still valid. Now, it would have crashed, right? It still has 46 to go. It would have crashed the source. But it's actually the dest that crashed first. So you can see here that it wrote the 243 out. Let me just take a look here. Let's take a look at what was in the previous ROP of both of these guys, just so we can get an idea of what that was. Yeah, so it copied this 243 to this 243. It did that copy, right? But then when it went to advance the source, it was like, oh, I could read, another 243. That would be just fine. And then the dest was like, I can't read the memory. Now, what I want you to build in your mind here, because again, we're trying to debug a fairly complex circumstance. So I would encourage you to really try to visualize in your head as you're going through this, what is actually literally happening here, right? Well, what you can see is there's an LZ based compressor, right? It's an LZ style compressor. What that means is when I'm reading source and destination, in like this case here, right? What I'm doing is I'm reading from the destination and copying it into the destination, right? I know it seems weird because normally we think of copying from one place to another and they're different. In this case, they're the same. Now I'm copying slightly offset, right? So that's why it works. I'm not copying from literally the same place to the same place, otherwise it would do nothing, right? I'm copying from a little bit offset. So I'm just a little bit back. I'm reading a little bit backwards and writing a little bit forwards, right? Or maybe a lot, depending on the jump. But what I want you to understand is, so the source and destination are the same block of memory. And if we look at what their actual values are, do you see this? They're very close, right? What's the source plus 1? It's the destination, right? So even just from this one stop here, I can see the thing that we sort of went out on. Now, we don't know this was the cause of the error, because it could have been multiple compounding errors going forwards. We have no idea where the actual bug is. But the actual cause of the stoppage was a rep instruction where we were told to basically copy a byte many, many, many times. Now, what do I mean by that? Well, in an LZ compressor, and I covered this before, so hopefully those of you who have your thinking caps on will remember what I'm talking about. In an LZ compressor, it can go ahead and encode effectively a run length encode, right? An LZ compressor is normally made to take chunks of data and move them forward, right? Oh, I see this thing and I want to copy it here because I'm repeating myself, right? But it is not limited to that. It can also repeat the most recent chunk of data, however long you want, the most recent thing. That thing can be repeated an infinity of times. Well, not infinity, whatever the maximum repeat count is, right? How do I do that? Well, let's say that I copied A, B, C, D, E, F, G, right? And that's what's sitting in the destination. And now I'm going to write after it, right? Well, if I just tell you to go back to the A and copy 20,000 characters, what will you do? Well, you'll write A, B, C, D, E, F, G into the output. Then you'll start reading from the place that you just wrote A, B, C, D, E, F, G, which will cause you to write another A, B, C, D, E, F, G, and you'll just keep rewriting the thing you just wrote over and over and over again. So an LZ compressor has a way of encoding effectively a block that just repeats many, many times. All it has to do is first do one copy to somewhere way back into the stream to find the block it needs, copy it once. Now it just says go back however long that block was, and then just however many copies it wants. It can just kind of copy it ad infinitum, blah, 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 right? Because it'll just keep taking the block, writing it into the destination. Now it'll start reading from that place, right into the destination, read from that place, right? And it's always one block behind itself reading and one block behind itself writing. That's exactly what we went out on. So we faulted on a place where we had some kind of a length where we were told you need to repeat the value 243 for a long, 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 long time, right? So we need at least 46 of these, right? Who knows how many it actually was. We don't have an original length here. The len tab symbol was 258, so I think that means it was at least it's at least 258 long. And the distance here was, well, we know what the distance was. It was one backward, right? So we don't know what the actual length is because we don't know what the extra bits are because obviously, how could Visual Studio ever show us the value of extra bits because it was in this other block? I mean, it's impossible, right? I mean, how could you ever do it? Let's not ask for miracles. Inspecting a variable that was used just a few lines before is probably completely out of the question. I don't know if even in debug mode. Don't ask me. It used to work. I don't know if the compiler now overwrites those values even in debug mode or something. I'm not sure. But anyway, neither here nor there. Visual Studio, as always, happy to not help you. But point being, this length was not 46. It was 258 or more originally. And then we started copying that 243, and we just kept on copying. So instead of stopping at the end of the buffer, where we should have stopped, we just didn't, right? So what I want to do very quickly is I want to go ahead and see what happens next. So I'm going to go ahead and set length equal to 0. I guess I'll do 0. And then I'm going to go ahead and let this thing bottom out. So now we're outside of this function. I want to see what comes next, right? So it's another 258. Oh, so 258 bits used is 0. So I guess there would be no extra bits anyway. So Visual Studio didn't really screw us too hard there because it turns out that extra bits wouldn't have been necessary. So the fact that it never lets us inspect any of these variables doesn't matter because they weren't actually used in that case. So we know it actually was 258 was the ROP, right? The distance is 1 again, and off we go. Okay. So what we're looking at here is a bunch of ROPs that seem to be going too far. I'm going to just start by looking at this routine a little bit more closely. This is not because I suspect that the bug is here. we haven't really spent much time looking at it. I just want to quickly, before I start digging deeper and making some test cases in here and stuff like that, I just want to quickly verify to myself, because I don't really know, that I didn't do anything obviously stupid with like those tables or the way that we're decoding these things. So I want to just look at this and get a sense for whether or not I've decoded this properly, right? So we're doing a literal or length Huffman decode here, and that, one thing we could have screwed up is these Huffman tables. So we're doing that decode here, and then we're going to output literals in the case where we ended up with binary codes less than 225, right? We're going to write those out. So that seems pretty straightforward. That case doesn't seem like it's probably all that unlikely. 256 is actually our stoppage case. So you'll notice 256 just falls out to nothing. In the case that we're over 256, we then have this sort of len tab index thing. Do we use lit len anywhere else? We don't. So basically we immediately take that and turn it into something we can look up into the table. You can see us looking it up here. And basically what we want is our length to be read out of there. Now, I want to go back and look at that table calculation. I want to look at all of this stuff. I want to make sure that this makes sense, because I don't know that it does, right? So I want to kind of get a sense of whether this is working properly or not. So here's the length extra lookup table that we've got here. Here's the PNG dis extra. These are the two things that we're looking these up into. So if I look into this table, looking up the bits here, so that means we jumped all the way to like this one, right? If it was 258 with 0 extra bits, that means that we were encoding value 285 into the table all the time, which was this one right here, right? And that, again, doesn't consume any extra bits. It just uses the straight 258 length value. So I'm going to go, again, I want to like just validate this table, and I also want to look to make sure that I'm interpreting that case correctly and not doing anything stupid in this case, right? All right. So here's that deflate algorithm here, and here's that table that we looked at before. So if we got value 257, we expect extra bits of 0 and a length of 3, right? So here's 3, 0, right? It's like 3, 4, 5, 6, 7, 8, 9, 10 to go all the way to 264. So 3, 4, 5, 6, 7, 8, 9, 10 goes to 264, and that's good, right? Then we have 265. It starts at 1, sorry, it starts at 11. Yeah, starts at 11 and reads 1 bit, 13, 15, 17, 19, 15, 17, 19, 23, 27, 31. And those are 4 2s, right? 2, 2, 2, 2. Then we go to the 3s, 35 and 43, 35, 43, 51, 59. Yep. 67, 83, 99, 115. Those are our 4s. 131, 163, 195, 227, 258. Okay, so I just wanted to spot check that table. We hadn't really looked at it much. Looks reasonable. Let me just take a look at this one as well. Just want to, again, make sure. We've got our extra bits here. There's 4 zeros, and the distance is 1, 2, 3, 4. 2, 3, 4. Then we've got, let's see what we got here. 5, 7, 9. Oh, sorry, 5 and 7. Yep. 9, 13. Yep. 17 and 25. Let's see, we got 3349, 6597, 129 and 193. 257, 385. Yeah. 513, 769. Let's see. 1025, 1537. 249, 2049, 3073. Those are both 10s. 4097, 6145. Those are both 11s. 8193 is a 12. 12289 is a 12. 16385 is a 13. And 24577 is a 13. Okay. So I think those are right. Series of symbols drawn from three conceptually distinct alphabets, either literal bytes from the alphabet of byte values, length backward distance pairs where the length is drawn from 3 to 258, and the distance is drawn from 1 to 32, blah. In fact, the literal and length alphabets are merged into a single alphabet where values are to the value 267 a block, 227 length codes, extra bits that follows, blah, blah, blah. Okay. The codes for the extra codes shown above. We show the codes table for added clarity. Literal length values 286 and 287. Will never actually occur in the compressed data, but participate in the code construction. Okay. What is meant by that? Distance codes 0 through 31 are represented by fixed length 5-bit codes with possible additional bits as shown in the table. And 30 and 31 will never occur. All right, so I just want to make sure I understand that last part there. So when we're creating these tables for the literal length Huffmans here, so when we create these Huffman tables, we're going to read in how long the table was. So basically, I don't know that we care about that part because it seems like they would have told us whether or not those things, like when we actually read the hlit value in, the hlit value will tell us how many things participate in the table construction. So I don't quite get that part of it. Not feeling great about that. Not feeling great about that. Yeah, I might want to look at that. Anyway, we have the lit-len dist table, the lit-len dist table. Let's let's see. So it's 32, so it's 64 plus 257. Yeah, that's going to fit in there just fine. I should probably assert here. Ooh, what did I just do? There we go. So I'm going to go ahead and just assert in here that the length count is less than or equal to the array count of the lit_len dist table. Just because I don't know why I didn't put one in before, but that's like a hard bound on that, obviously. So, yeah. So coming through here where I do the compute Huffman, we should look at those Huffman codes. So the Huffman decode, then when we grab out this part here, we look up the Huffman decode. So we subtract 257 from it because that's the base value. That seems correct. When we look up into our length table, we start with whatever the base value has to be. We then look at how many bits we consume extra. From the input data, we grab those bits and we just add that in as the additional length value. We then go into the dist tab index. That Huffman decode is using the other Huffman table. This one, so I feel like, and maybe I'm being premature, but I feel like this part is not relevant. Well, that's not true. So this part cannot cause us to be wrong in the way that we were wrong, meaning we weren't fetching off the beginning of the buffer, so our distance value, even if it was wrong, isn't causing the problem. But I shouldn't say that it can't still be the cause of the problem, and the reason for that is because if you look at this extra bits situation, because reading the Huffman out of here then tells us how many extra bits we should read, if this is done incorrectly, it's the Huffman table was built incorrectly, we will get the wrong symbol value out, and that will then cause us to read the wrong number of bits. When we read the wrong number of bits, we put our stream off by some number of bits, and then everything subsequent will be wrong. You know what I'm saying? So even though this itself, getting the distance wrong is not relevant, getting this number wrong is not relevant to the to getting the wrong number of bytes in the output, but it still can be the cause of that problem because of the stream offset, right? So yeah. So what I could do here too, we could stop a little earlier. We could basically say, like, we want to make sure that the decompressed pixel ending is not going to be something that gets exceeded. So I can do this. Right. And so that should, I think, if I wrote that correctly, that should assert prior to us writing off the buffer. So here we can look at what the values were going to be, right? Like we surmised it was 258, it is. This allows us to see who is about to produce the problem. And so in this case, actually everyone will, like the dest and the source will both exceed. The dest will exceed it first. but the source will exceed it as well, right? So they both would have gone off the end in either case, right? So the other thing we can look at here is I'm interested to know as well the decompressed pixels end. No, I guess that's all I really need to know. All right. So I would say that we kind of have two avenues to go down now to try and figure out what is causing the problem. One route is to go down looking at the Huffman table calculation and see if we have problems with it. Seems plausible that there'd be a bug in there. It's a little bit of a weird routine. However, I don't have anything to compare it against, right? So my main problem with starting with the Huffman table is I don't have any way to take some known good data for what the Huffman table should be and actually look at what mine is and go, oh, there's the problem, right? So that seems implausible as an avenue. So the first thing I might do instead is actually just look at the lit-len part of things and see if I can't get that to give me a clue, right? So the first thing that I want to do here is I want to take the images that we have, and I've got myself into a situation, right, that's a little bit unwieldy. All of these nice, tiny, easy to inspect images, they don't have any bugs, right? Well, I shouldn't say that. They don't have any of this bug, the kind that we're looking for. Maybe they don't produce the right image we haven't tested yet, but they don't have any obvious bugs. This one does, but it's huge, right? I mean, we look at the properties of this thing. It's a monster. It's 1024. I'm not going to inspect all that. So my first question is, can I make this error occur without needing the full image in question? And so I want to basically try just dicing this image up and seeing whether a smaller version of the image will cause the problem. So what I'm going to do is I'm just going to take the crop tool and I'm going to split the image in half and see if it's still... I'm basically going to do a manual binary search to see whether I can produce a smaller image that still reproduces the problem, but that I can visually inspect so I know sort of what's going on. Now they changed all the icons in GIMP, so honestly I don't know where the crop is anymore. Probably that. That's not at all what it used to look like. All right, so what I'm going to do is I'm going to take a 512 by 512 sub piece. You can see down here there's a pixel counter. So I'm going to look for 512 on both axes. And I'm taking the top corner. And I probably could have done this just with the... In fact, you know what? Here's an easier way to do it. If we just did canvas size, I can do 512 by 512. And we'll just take that upper corner, right? So now I'm going to say, like, okay, resize it. We've just got this. So now I'm going to save this as just a generic name, test2, right? Or maybe test small. And I'm going to export that. So now what I'm going to do is I'm going to keep loading this in until I can get it to I'm going to keep making it smaller until it doesn't crash. And I'm going to take the one that's just a little bigger than that, right? Oops, that's not what it's called. There we go. All right. So let's say I go through here. So now I don't crash. So even just that split, just that split by itself causes us not to crash. That, again, pretty rough on us. It basically means that we're in a situation where this must be a fairly subtle problem we have. But hey, we've got to fix subtle problems. We can't only fix glaring problems, so let's go for it. So I'm going to try a different thing now. I'm going to try having the image only this way so that we still have runs that are large in that direction and see if that helps, right? are we actually parsing this thing? Yep, we are. All right, so it doesn't crash in that case either. Okay, not a good start for us here, folks. Try one more thing. Let's look at the bottom of the image. Okay, so this is good. We've produced a potentially different error. It's not necessarily the same, but it is still an error. That's good because they probably both come from the same place, which is probably a corrupted read, like a read that reads too many or too few bits and gets the whole stream out of whack, right? So what I do know is that I can use this smaller image, so let's keep trying again to get it smaller and smaller. So I'm going to go ahead and try to make it even smaller than this. And so the first thing I'm going to do is I'm going to try just the white part here. So get rid of that, the actual data. I'm assuming that the problem is in the actual data part, not in this, but we don't know. Maybe it's a problem with our large runs, you know, and in which case it could be that this part is the important part. So that part read through just fine. That also collapses down to a single IDAT chunk. I don't know if that's relevant at all, but it's worth noting. All right, so now I'm going to do the same thing again, but I'm going to try just with the upper chunk, right? So now I'm going to try just this top chunk here. So there's my resize again. Now I'm going to go ahead and do an export to GIMP small again and run. Okay, same problem. So this is good. Again, we're narrowing down the size of this thing. I'm going to get it even smaller now. Let's get it down to 128. Again, bisecting. Keep the top part. Still has the bug. I'm now going to split because I've gotten it. Well, you know what? Let's just see how small we can make it this way. Why not? Go down to 64. Okay, so I can keep the top or the bottom. Going to keep the top. Okay, so the top didn't work. Let's keep the bottom. Awesome. Still buggy. So we've got a bug case here that's getting quite small. Let me keep going. Down to 32, right? Pretty tiny. Keeping the top. Not buggy. Keeping the bottom. Okay. So we've gotten to a place where it looks like we sort of have to have both of these, or at least something else. I don't know. I mean, I could just for sake of argument try keeping the middle part of it like so. This. So that's just the middle. You know, who knows? Maybe. But it looked like we needed at least that big in order to get repro. Yeah. So it looks like this is our test case here. And that gives us an error, right? So now we got something at least much smaller we can look at. I will now try to bisect it the other direction. This probably won't work to reproduce the problem, but I'm going to try it anyway. So we're going to try just the left side. And now just the right side. Yeah. All right, so this is what I've got. It's not that small, but it's at least, you know, let me see what happens here too with this. So I will note that, again, the multiple IDAT chunk thing is interesting. Like, I just want to know. I'm so interested to know if that's related. So if I take it down to the 512 like I was doing before, and I export it, is it still 2 IDAT chunks? It's not. That's so suspicious. All right, so let me go ahead and, because like, I'm just wondering if that's all it is. Is it just that we have a multi-IDAT chunk bug? I can't imagine it is, but I'm really curious now. So I'm gonna take this down a little bit more, see if I can generate one that still has 2 IDAT chunks in it, and does that reproduce the problem? Just trying to find one that still has 2 IDAT chunks. I mean, don't you think that's really suspicious? I mean, it just seems really suspicious to me. I mean, that is just so suspicious. Like, I just don't know what to make of that. But it sure looks like something that's wrong with the IDAT chunks. I feel like we need to look at those IDAT chunks in the spec. So, you know, good news is we've got this down to a much simpler test case, right? I mean, that's way more straightforward than it was before. I'm going to now try one more thing before I go look at anything else. So I'm going to assume, let's suppose that we had highly uncompressible data that doesn't compress particularly well. It looks like GIMP breaks into IDAT chunks of 8192, right? So 8192 divided by 4 is 2048, right? And is this the square root button? It's like 45. So a 64 by 64 should be big enough that I break into multiple IDAT chunks, right? If the data is non-compressible. So here's a 64 by 64. I'm going to create something here. And I'm just going to paint a bunch of nonsense in here. Oops, not with that. I want this to have an alpha channel. I'm going to erase some stuff too. So I'm just going for something just hard to compress. That not hard to compress for, you know, any compressor, but specifically hard to compress for pain. All right, I'm going to blur this. So all the values are kind of wonky. All right. And now I'm going to try to see if I have made one here we go. I want to try and see if I can make one here that is still 2 IDAT chunks, right? A totally different file, but that has 2 IDAT chunks. So this is GIMP 64 by 64. And it helps if I don't type the name wrong. Okay. So did I make 2 IDAT chunks? Yes, I did. And do we crash? Yes, we do. Totally different file, right? And the only thing is it has 2 different IDAT chunks in it. So I'm going to go ahead and say that I am now fairly certain we have at least one IDAT chunk related bug in here. I don't know what it is yet, but I think we probably have one. So the first thing I'm going to look at is how I'm handling those IDAT chunks, and am I potentially misinterpreting the length? So for example, in here when we get this content size for the IDAT chunk, right, is it possible that that length gets rounded and I need to unround it or something like that to a certain bit length or things like this? So I want to basically read the IDAT chunk part of the ping spec and see if there was something we forgot, because it's been a while since we read that part, and there may have been something in there that was like, and we round up to blah, or whatever, right? So anyway, a 4-byte necessarily given the number of bytes of the chunk's data field. The length counts only the data field, not itself, the chunk type, or the CRT. 0 is a valid length. A coder's recorder should treat the length as unsigned, and it shouldn't exceed 2 to the 31st minus 1 bits. Okay, so we properly use the chunk header length, which has been swapped as the size of the data, and we use the chunk data as the data. That's what we'd expect, so that's good. Let's look at the IDAT chunk information and see what it says about how they work. So the 4-byte chunk type field contains decimal values 73, 68, 65, 84. I assume that's just IDAT, right? The IDAT chunk contains the actual image data, which is the output stream of the compression algorithm, see clause 9, and compressor details. The main multi chunks, if so, they should be consecutively with no other intervening chunks. The compressed data stream is then the concatenation of the contents of the data fields of all the IDAT chunks, which is what I think we were trying to do here, right? So we put together chunks of that size, right? We say, here's the length, here's the data, and we put it in there, right? And, you know, it can only be the length, it's not bit length, it's a byte length, so that's how many there are. When we look at the last pointer, we string them together, so are we correctly appending these? We say the last pointer is going to be equal to the chunk. That's what we want. We set the next pointer on the last one to this one or the first, depending on whether there is one or not. That seems right as well. So that should produce a singly linked list of all of them. So that seems good. Okay. So in here where we do IDAT headers, here's the IDAT header that comes in. I thought, and maybe I'm wrong about this, but my recollection was that when you move to another IDAT header, they did not have any more header information. I'm almost positive that that was true. So I'm pretty sure that that's correct. All right. It is important to emphasize that the boundaries between IDAT chunks are arbitrary and can fall anywhere in the zlib data stream. There is not necessarily any correlation between IDAT chunk boundaries and deflate block boundaries or any other feature of the zlib data. For example, it is entirely possible for the terminating zlib check value to be split across IDAT chunks. Similarly, there is no required correlation between the structure of the image data and deflate block boundaries or attributes. The complete filtered PNG image is represented by a single zlib data stream that is stored in a number of IDAT chunks. Well, I guess the first thing I should do is just look at how these are constructed and when they're read from. So, so when we're reading these, it's pretty straightforward, right? We consume bits looking for the B final. So it looks like here we've got a Huffman decode within the first block. And we read an invalid symbol. Yeah. So at the point where we read the invalid symbol, which buffer are we on? Oh my. So, yeah, that, I mean, in case anyone was wondering, that's not good. So, yeah. It underflowed. So this is just busted. Kind of says you're on the and file first. This equals file first. Content size. Let's step through that. So did this hit? It did. Oh, but that's the first one. So that never got hit, even though we set the underflow flag. So what we really want here is to look at this underflow flag. Yep. That's a bug, folks. You saw it too, I'm sure. Well, MTS Mock saw it because he said he debugged this earlier. So this is wrong. So basically what's happening, the problem here is consume is the thing that can advance. We wrote this before we supported multiple IDOT chunks. We failed to actually write it correctly. So what we're trying to do here is we're trying to loop until we don't have as many bits as we think that we need. You know, also, I'm going to put an assert in there. It would have caught this bug earlier. So if you look at this bit count, less than bit count, this part here, it needs to at least try to call consume, or it won't refill the buffer, right? So once we try it here, we could say like, oh, okay, you know, if we succeeded in getting a byte, then that's fine. If we didn't succeed in getting a byte, then we break, right? So that's, it really needs to look more like that. This isn't right because if the buffer was only one big, we don't want to break out. So it's like we need some way of consume actually telling us whether or not there's anything that we got. And so, right, we need some information from consume about what it actually returned, right? So, you know, oops. I'm going to go like this. And say that this flag is now like a thing that we have that's part of the consume call. So like, something like that. So basically now the underflow flag gets set outside and consume size. This thing will keep going, trying to get more bits until the underflow flag gets set, at which point it will bail. And off we go. So now let's see if we get any more love here. Hopefully we can start to figure out what's going on a little bit better. All right, so I don't know if I still screwed it up there. Let me make sure we recompiled this here. But let me see if I can get it now to the point where we're actually reading that, because that was definitely a bug. All right, so now we're at least actually reading the real bits in. We did actually advance. What I don't know is, did we advance correctly? So we're still, it's a little bit odd here. I still think we might have a little bit of bugs. We did advance. This doesn't really matter. We did advance, and we read all the way till 13 bytes from the end. And then we got a bogus symbol, I think, right? So that looks like what happened here. Don't ask me why I have that in there twice. So that got us significantly further, right? So that was a pretty major bug. I'm also assuming that that was not the bug from this one, but I don't know. It was. Okay, so that was actually the bug we were having on the test case. What the heck? What is scripted sandbox 64? Just what is it? Oh boy. Anyway, so I guess that was the bug that was causing us to put the wrong number of symbols in there. So I guess now we actually have to focus on this other case, because now that case is actually not buggy anymore, which is great. So never mind. But I do want to find out why our 64 by 64 is wrong, so let's go ahead and get that one going now too. All right, so this one is reading an incorrect symbol at the end, where we're getting some symbol that we don't think we should be getting, one that wasn't supposed to actually occur in the input stream. So I don't know what the bytes we actually got here. Okay, so we got 11276 as the bits that we got. 15-bit. We got 11276 as the bits that we got. Those bits don't map to anything. That's like they were not bits we actually ever expected to see. So we're like, what happened, right? Okay. Now, I still don't really know that we fixed the bug that we had. I tried to fix the bug that we had, but I don't know that we did. So what I would like to do is just verify that I think that loop still works. So while the bit count is insufficient and we have not yet underflowed the buffer, it will try to consume new bytes and shift them in, right? And that seems relatively straightforward. It will then take the bit buffer and, the peak bits just uses those bits, and that's it, right? And then you can discard the number of bits that you actually used, however many that was. And that seems reasonable, I guess. All right. So now I'm going to have to progress through this one as if it's a totally new test case, though, because although I fixed one underflow problem with the IDA, I also want to make sure I did that test right. We had two of these, right? We had GIMP test small. Yeah. So, and you know what else I want to do too? While we're at it, just to see if these test cases are really producing the right amount of data, I want to assert that the destination equals the end. So when we get here, I want to assert that the last thing we wrote is where the end of the buffer should have been, right? Because maybe it's not actually producing it. Okay. So now we've made quite a bit of progress. I'm pretty happy about that. That was a pretty stupid bug to have, but it's just because we updated that thing, right? And didn't update the part of the code that actually needed to care about it. So now it looks like we've pretty much got everybody producing the right amount of data except for our 64 by 64 friend here, right? And our 64 by 64 friend here is actually really close to the end, I think. Let me see. I don't know how close to the end of the output it actually is. So it's only 9 bytes away from the end when it encounters a bad symbol. Of course, it may be totally wrong data, so that may not mean anything, but it's just worth noting. And also, as we know, the input that's actually reading from, the comp data is actually been processed almost entirely. It's got 13 left for a 9 actual bytes. Right? All right. So this one's going to be rough because this... So I guess there's still 2 things that could be wrong here. So one could be that the Huffman table was built incorrectly. And this symbol that we actually got is a symbol that could be encoded. So, it's possible that the data stream is now functioning correctly, but the Huffman table is functioning wrong. However, it is also the case that that's not true, and that what actually happened is we still have a bug in the bit stream reading across IDAT chunks that only happens at certain times. So I'm going to check for that first, and here's what I'm going to do. I know it's going to look a little weird, but what I want to do is I want to look at the peak bits call, and you can see where we're doing this consume here. I want to know when we do, so if buff content size is less than 8. So if we're going to advance forward, I just want to know how many bits were in the bit buffer. That's it. So I just want to say, look, here's how many bits I had when I went to wrap. I'm just curious. Don't ask me why. I just want to know if there's a difference between the cases that do work and that don't. So that tells me something right there. Oh, sorry, I meant 1. So I guess it's just 0. If I was about to advance the buffer. So there were 12 bits in the bit buffer before I went to advance. Fixed Huffman, not yet. Oh. Oh. So that's actually just one that we don't handle. Oh. Ah. No problem. It's fine. Well, I'm glad I looked at the output. Good. That gives us an excuse to go do that now. So maybe we don't have a bug. We don't know. Maybe we don't have a bug at all. What we do know is that we need to put the fixed Huffman tables in now. So let's put them in. Seems like as good a time as any. Looking back at our specification, we have to find some... Okay, here we go. The Huffman codes for the 2 alphabets are fixed and are not represented in the data. The Huffman code lengths for the literal length alphabet are 0 through 143 get 8 bits, 144 through 255 get 9, 256 through 279 get 7, and 280 through 287 get 8. I mean, is that as simple as it sounds? Is that all I have to do? I mean, I'll just try it, I guess. Can't hurt to try it. So basically what I'm trying to do here is just seed this Huffman table. So, this nonsense here, I still want to do this, this bit right here. So I still want to produce these two, but I don't really need to. He says, I don't really need to look at the... Hold on. So where where does the distance Huffman? Oh, here it is. Blah 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 blah. Okay, so that's when I read this before and didn't know what it was talking about. It's talking about only the fixed codes. This is not a new header. That's just a page break. It threw me off. Distance code 0, 3, 1 fixed like 5-bit codes. Distance codes 3 that would never occur in the compressed data. Okay. So let's start. So 287. Okay. So what I want to do here is just seed these in. So let's go ahead and actually do this. Here's the lit-len dist table. In fact, I can just, we can just make this thing happen out here. So here's the lit-len dist table. I can go ahead and just fill that thing out. We now know that hlit will basically be fixed. So the number of hlit codes there are is now non-variable, right? Because it's a fixed open code, so don't read it from anywhere. And so we know that the hlit value actually goes up to 288, right? Is the first one, because 287 is the last code that actually participates. Yeah, 287. So 288 is the first distance code, if I'm understanding that correctly. So I'm going to go like this. And I'm just going to write stuff into that lit-len table. And so all I'm going to do here is just say, well, the bit count, I don't remember what we actually made these things, U32s. So the bit count here is going to just be based on where we are in the actual stream, in the thing, right? And you could make these into multiple ones if you wanted to. Multiple for-i loops, but I'm not even going to, well, yeah, I mean, I guess I could do that. I mean, let's just do this, right? So what I'm going to do here is I'm just going to do like the stopping point and the bit count, right? So I'm just going to say what this thing says. So it's like, okay, we've got 0 to 143 are going to be 8 bits, right? So I'll just do like 0 to 143 are 8 bits. 144 to 255 is 9 bits. 256 to 279, so that's just 279, is 7 bits. 280 to 287 is 8 bits, right? And then the length values, which go on after that, are 32. Is that correct? So it'd just be like 319. So I think that's what we're talking about here. Don't quote me on that. So if I want to set the bit count index, maybe we'll do it like this. Oops. So here's what I'll say. I guess we'll call these range indices. So, yeah. How's this? What do you think of this? It's not fabulous, but I think I get the job done. So basically what we do is we start at bit count index 0. We need to fill out the whole table. We have a little cheat sheet here that tells us like what to go up through, right? And so wait a minute. So 288 plus 32 is 320. Yep, so we're good. So, we just read out, okay, what's the stopping value for this range of bits? And we just romp that value in there. Then we do the Huffman table based on that the exact same way we would have done the Huffman table, which is good because I think that means we can just do this and get rid of this part here. And that way we can just have hlit and hdist be variables that actually get set separately. And off we go. Okay, so wait, what? Index undeclared, where is that? Where are you seeing index on that line? So confused right now. Did I do something really strange here? Whoa! Whoa! How did that get over there? My bad. All right, so now that we got a fixed Huffman case here, let me just step into this one time and see what we get out of it. So I'm going to look at this lit-len-dist table nonsense and just see if it set up what the spec says, or at least is what I configure. So we expect to see 8s going from 0 to 143. So there's a bunch of 8s, and there's 143, right? Now we've got 144 to 255 should be 9s. Okay. Now we've got 256 to 279 should be 7s. And now we got 280s to 287 should be 8s. And then everything after that should be 5s. I just don't know how far up the 5 should go. I think my feeling on that is that it should go up to 319. But I don't know. We exited properly, so, maybe we're good. I don't know. So at this point, we're kind of now at a place where we need to start figuring out, okay, we're not obviously erroring out in the middle of stuff, but we don't actually know, we don't actually know if we are producing reasonable images at all, right? We did a little hand inspection, but it would be nice now if we could diff the image or something to determine whether or not we actually have an exact replica or if we've got pixel errors. So I don't know where we are on time. I think we're almost out of time, actually. I think we're only 10 minutes to go. So what I think I'll probably do is just run a few more test images through it first. What we'll do next weekend is we'll actually just start putting in real images to it and test them versus like a bitmap version of them that we can load exactly and diff them, so that we can then just verify that we actually have what we think we have. If I remember correctly, we've got a case that's still asserted out and we've never called it. So this guy, the averaging guy, never got used. So I don't know what to make of that. Like, we still haven't asserted in there. I'll go ahead and remove that assertion temporarily, but like I'm gonna leave the to-do in there because at some point it would be nice to figure out whether that works. Right. So let's go ahead and take I don't know the best way to do this here, but let's suppose that we went to twitch.tv /handmade hero and just took a look at this nonsense that's going on here. Surely we want the 1080p version, right? This nonsense that's going on here. And then what I could do is just capture this and try to save it, right? So what I'm going to do is screenshot snipping tool. Let's go ahead and let that play. So we'll do a new here. We'll grab it. There we go. Let's go ahead and let that. And now we'll save that out as an image. And we'll save it from, as a PNG from a different program. This is from the snipping tool, just to get something like totally different in the mix that I can test against too. All right. So let's see what happens when we throw that at it. Maybe that'll expose some more bugs in our stream handling that we haven't thought about yet. Sorry, as I forget literally the file name I just typed in, hh_capture. So that's good. It looks like we ran okay. So I think we're at the point now where our stream handling isn't too bad. A lot of IDAT chunks in there. We decompressed. We didn't exceed our boundaries. We produced the exact right amount of data. So that to me suggests that we are in reasonable shape, right? Okay, so let me go ahead and put a QA up on there. Let me also ask, so MTS Mox, you said in the pre-stream that you had worked to find the bug. So did you find it? Was that the one that you found? I'm curious to know. Awesome, okay. So do you think that took me a reasonable amount of time to find, too long, or not? I don't know. You said you thought it took a long time to find. For you, I don't know. You could use the raycasting code for save image files so we can see what happens. It should be a quick thing to do. That's a good point. Handmade Ray, which we did when we were starting to test this new streaming machine, does have images that we can use. So here's an example of a bitmap version of the image. And oops, I don't know what I just did there. Oh, it's just this. I just want you to use this, Microsoft. Where's GIMP? Why isn't GIMP on there? All right. So here's like a thing that was produced by the ray tracer, and here I'll export that to the test directory as a PNG. Guess I don't really know what stuff to put in here, but sure. See how that does. So great, I'm really happy about that. That seems pretty robust now in terms of handling the stream. I mean, that was a lot of stuff to get right, and we got it right. We only had one real nasty bit there. We do have to give credit where credit is due to somebody who probably saved us some debugging work coming up. Because remember, our filters could all be totally busted right now. We have no idea. We haven't really checked. But I guess what I would say is somebody mentioned the fact that I had read the spec wrong about the B value being too high up, being one above, not two behind. So, or the C value rather. So that one was somebody cheated me on that one. You purposely screenshot my message saying you are handsome. No, I didn't. I didn't even notice that. Frosty Ninja, I think he meant save out the decoded PNGs as a raw bitmap so we can see the result. Oh, I see what you're saying. You're saying use the bitmap saving code. You know what? That's also a good idea. Both the idea that I interpreted you as saying and the idea you actually had, which not the same, are both good ideas. Yes, we could. We did write on Handmade Ray a bitmap thing here somewhere. I don't remember where, but we do have one in there that saves a bitmap. Anyone remember where that is? Here it is. So yeah, we could totally do that. That's pretty trivial to do. So if we want to just dump that in here, we would just need the bitmap header struct. That bitmap header struct, I don't know if it's already in here. It might be. Yeah, it is. So all we would really need to do is like put the width and the height in here, and then put that in here. We don't have the bitmap header. But we do now. There we go. And then this image pixels bit here is just going to have to be something that we pass in. Yeah, so that seems good, maybe, I don't know. But yeah, so after PNG filter reconstruct here, what's going on here? So we can do do we have a temp directory? I don't know if we do, although it's filled with other stuff in it though. Maybe it's time to clean that out. Rename temp to old temp and make dir temp. So, you know, something like this ish. So that'd be pretty easy for us to implement, right? We can just say like, if arg count is greater than equal to 2 or equals 3, right? Then we say like, okay, the in file name and the out file name. So then we do like that. And just, pass this thing in here. So honestly, I think actually the way this thing had it before, though, with having a package that you return is probably a good idea, right? So we probably actually want to keep that thing that it had before to a certain extent. Because this thing here, this parse PNG, is going to have to return something. And, it would be nice if it could return the metrics of the file as well. So, this image U32 nonsense that we introduced in here somewhere is actually probably the right thing. Or not necessarily the right thing, but, like, it's useful. So, we can just dump that in here and say, like, okay, yeah, this thing returns one of these. And then you can just do this. And, it's good to still have this take the broken out pieces, I kind of feel like, because there's no sense in not having to do that. But it's good to have this for the return value. So that seemed useful to me. So I'm going to keep that as it is. So if this returns an image U32, I'm just going to say that there's a result one here. When we come through here, we've got the final pixels. The width and the height are things that need to be out here. But at this point now, when we come down here, I can just basically romp those in I don't know why I defined it at the top. Yeah, that was not necessary. So this can actually just happen down here. It's just like a way to bundle up the information that comes back, like so. And so now at that point, that should be fine. And maybe that'll work. I don't know. Let's see. So there's our temp file. Whoa, okay. So it looks like we have a couple problems. So all of these, I think, are not problems with our reader, though. So first of all, the PNG comes in RGBA. The bitmap goes out. The other bitmaps have the byte reversed version. So there's that. Bitmaps also flip upside down. So those two things we would have to handle, but otherwise I think we're good. Like, I think that's just correct. So that's, yeah. So when we, let's call this right image top-down RGBA. What this would have to do here, I think you can do that. I think we can do that if we want to. But since we have to reverse the channels anyway, what I could do here is just do the row swap at the same time I do the bit swap. So what I could do is say, all right, row equals 0, or I should do this, y equals 0 less than header dot height over 2. I want to round that up. I'll do midpoint. So basically what I'm going to do is say, like, look, let's go to the halfway point here. And what I could do is take two rows, swap the two rows, and swap the R and B channels, which should give me a valid bitmap out. In theory, right? So basically what I can say is like, you know, row 0 equals, well, I can do it like this actually. So row 0 equals pixels, row, you know, 1 equals pixels, plus the height times the width, like that. So just get me to the last row. So now I've got pointer to either, right? Either one. And then each time through, I can just do like, in fact, you know, yeah, well, row. So step 1, you know, from the top down, the other from the bottom up, right? And then we can just go through and do the pixels, right? Pix 0 equals row 0, pix 1 equals row 1, for u32x equals 0, x is less than width, plus x. And here I just need to swap the two, right? So C0 equals pix 0, C1 equals pix 1. I've read out both the colors. Then I will just write them back together here, although actually I guess we'll just swap them, right? And so now what I need to do is swap the R and the B of each of them. Maybe I'd do it like this. No, I'll do it like this. So I'll swap the R and B of this, I'll swap the R and B of that, and then I'll just write them out in the opposite order, right? So that flips the image, I believe, and flips the R and B channels, which I need it to do. So then all I need here is a thing that will do that swap. So when I say swap R and B, like there's the color or the input, and so if you think about what's going to happen to these to the values, right? The alpha and the green stay in the same place, and only the R and the B swap, right? So to produce the result value, if I just start writing this out longhand, I know that I can knock out the values in question like that. So this will leave me with just the alpha and green channels intact. Oops. Sorry, I'm a little fat finger today. So then the question is just, what else do I have to put in here? Well, I need the red channel to, well, it depends how you want to look at it. I need the input that went here to slide down. I need the input that went here to slide up, right? So I need to slide down 16 bits and or in what would it be in the low at that point, right? So just slot in whatever, that's taking what was here and sliding it there, right? So that's one part of it. Then I need to take the bottom part and slide it up, right? And what I can do there is just AND it with OXFF first, then slide it up, so that I still use the same mask both times, right? It's pretty simple. I think that swaps them. We'll have to double check. Excuse me. I meant to type that. And so now that was pretty quick and dirty, I admit that, but I think that might be what we wanted. Let's take a look. Okay, there's no way that produced exactly the same image. Oh, I forgot to advance those pointers. It didn't produce exactly the same image. It produced almost exactly the same image. It only did the first column. So yeah, right there. Sorry about that. Try that one more time. So there's the there's the image that we produced from the ping. And if I go look at the test data that we got, here's the input ping. Now, I'm not really sure how to diff these two exactly. If we had like beyond compare or like one of those utilities, we could just ask it to diff. I don't know if GIMP can diff. It sort of could, right? Like what I could do is this. Open Handmade Ray. Open, temp. Oops, I meant open as layers. Temp. And then set this layer to subtract. And see what we get. So that's what the difference says. I don't know if that means we've got some bugs on the outline here. If I don't set it to difference, can we see those bugs? Oh, it looks like we shifted the image. I wonder if that's because my swap. Like we shifted the image. Did you notice that? Is that true? Let's take a look. I'm looking at the top. Yeah. So the image is shifted up by one. What happened at the bottom? Oh, there's no way to tell, is there? Because there's nothing on the bottom. There, it's blank. So that's, I think we're good. It just, this right bitmap is off by one here. So let's see. So I can't, I'm sure that I should be able to immediately see what the problem is. Oh, that was just straight up typo. Don't ask me why that was doing that. All right. So if I now run this, we should now have an exact version, hopefully. So that's the one in the actual temp directory. So that's the one we produced. Let me open as layers the original one. That's in Handmade test. Handmade Ray. And so let me set that to difference now. This is not really correct because it won't handle overflow and underflow, but at least now we can see that there's no obvious glaring errors. So we're doing pretty good. Not bad for a Sunday. Let me take some questions. Isn't it true that the compiler's optimizations of your code and the way the CPU works and sometimes cause instructions to happen in a different order than you wrote them? If so, won't that screw up profiling measurements? Yes and yes, I guess is what I'd say. This is off topic, right? Because we're not doing profiling measurements today. I mean, you're not asking a question about what we're doing here, right? That's just a general question. The answer is yes, it can, and yes, it can. Both of those things are true. Can you quantify how fast you type? Not particularly easily, because most typing measurements just give you words to type, which are different than typing code, so it's a little hard to say. It's like, what do you mean by how fast can you type, you know? Would you say that 4Coder is the ideal text editor? Well, probably not the ideal text editor, but it's like the one that I prefer. I mean, the ideal text editor would have all sorts of crazy stuff in it. I mean, Alan's only been working on 4Coder for not that many hours, right? So I feel like I don't think he thinks it's the ideal text editor either. He's got tons of things planned for it that, you know, will make it better. How often do I work out? I do not really work out per se. I go rock climbing, which kind of just ends up being a workout. In the bitmap write routine, I think you have a bug, advanced row 0 too soon. Yes, you are correct. We just found that one. Double check the shifting. It's not a git paster error. It's not. It was just us. It's just us. It's just us. Just joined a week ago and haven't had time to go through all the series. Can you say in overall what have you done on the project and what is left to do? So at this point, we're basically putting art in. After we're done putting art in, we're gonna mostly be doing gameplay programming, which is like programming like, you know, NPCs hopping around and you interacting with the world in ways and stuff like that. That's what we have to do now. And along with that, there'll be world generation code stuff, because we just have very simple world generation in there right now. We will do some passes on the graphics later to add more stuff, like more like good particles and stuff. We have like some sort of placeholder stuff in there for some things, and those things we'll have to improve. Do you have any project recommendations for beginner intermediate C programmers? Which kind? So the one I usually say for game programming is Asteroids. It's like the easiest game to write, so it's a good one to start with. If you're not talking about real time, or you want something has no platform dependent parts, Ray Tracer is good. Seems a bit casual today. What's your favorite album? Oh. What's my favorite album? You know, that's real tough. I don't think I can pick a favorite album. I really just don't think I don't think it could pick one. I'm sorry. What is the craziest file format to parse? Well, I guess I don't know what you mean. So, the craziest file format you might try to parse in practice would probably be 3D Studio Max, because there is no text version. It is binary, it is undocumented, and it depends entirely on which plugins are active. And it changes with every revision. So probably like reading Max files directly would be like one of the most nutso things you could do. I'm sure there's harder, but that's just the one that comes to mind. What is the most difficult file format to read? Have you ever tried to read TTF files and tried doing a vector renderer for those? TTF files aren't bad. Yeah, no, there's way worse stuff out there than that. What's my favorite pasta dish? So I think I would say that a straightforward sausage rigatoni would probably be it. Like red sauce sausage and rigatoni, like it's a pretty standard Italian dish. I like that a lot. How come no one has made a solid debugger? Is it difficult? No, it's not particularly difficult. I think the problem is it's not particularly profitable. I think one of the main issues that we face these days, I guess I would say developers don't pay for software much. They expect everything to be open source and free now to a large extent. And the problem ends up being that there's no money in it to make these tools. So as a result, no one does, and you just end up with like crappy free stuff that isn't very good, or like the one remaining tool from Microsoft or something. Will the game be only room-based? I don't know. We have scrolling in there, so I don't know. Am I a musician? Not really. I can play the piano, though. Did you write music for Handmade Hero? No. I'm not writing music for Handmade Hero. How can I send data over the internet for a game that can be picked up in a code that I write? Well, usually you use sockets for that. So usually you use like recv or send to send packets. I mean, I'm not sure what you're asking, but that's how that's done usually. Will we be parsing compiler debug output for cool game debuggers? No. We're not going to parse Dwarf. Dwarf, speaking of disastrous file formats. 3DS is worse than PSD. Oh, not 3DS. Max. 3DS files aren't awful. 3DS files aren't great, but they're not awful. Max files are awful. .max. Way worse than PSD. Way worse. We've had a Handmade Ray bonus series. What about Handmade Asteroids? Maybe someday. I don't know. No promises. All right. I'm calling it a day. Hey, we made a PNG reader. That was cool. First time I ever parsed PNG. Never had to write it before. I will probably go move that into my code base too, because why not? Now I don't have to use other people's code to read a PNG if I want to. I could also make something that writes a PNG now that I think about it, because it wouldn't be very hard to reverse and to go the other direction. Anyway. All right. So I want to close this down because we don't need all these specs anymore, but if we encounter bugs in the future in our PNG reader, it'd be nice to have them. So what I might do is just say, like, let's make a little PNG docs thing here so we don't have to go dig these up again. And let's just drop these in there, the links. Oh, you know what would be even better? Let's just save the documents. Because these are text files, aren't they? So can I just save this thing? Of course, this wouldn't have the diagrams, would it? Like, what's this thing? It's a ping. Well, I mean, it could still load the pings, I guess. I don't know. So all of these are would just save, right? We wouldn't have to save the links. We could just save the file. So anyway, now we've got those in there. At least these two we can open up as text, which is nice. These two, not so much. Looks like that worked okay. Yeah. So I'll just leave those there because, you know, we only know that a small smattering of tests seem to work properly. We have not done any robust validation of this PNG reader, so we don't really know that we've handled all the cases correctly, and we could, in practice, as we start using this in the game, find that we've got some art assets that don't load properly because maybe Photoshop does some slightly different things than GIMP does when it does compression, etc., etc. So we want those documents handy because we're going to have to refer to them again when we hit a bug, right? So we'll leave those there for now. But that way I don't have to keep them up here all the time. All right. Thank you, everyone, for joining me for an episode of Handmade Hero. It's been a pleasure coding with you as always. I'm glad that that PNG reader went pretty smoothly. I don't know. We only spent, what, 8 hours on it? 12 hours on it from start to finish, PNG reader. That's pretty cool. And now we can load PNGs immediately. So that'll allow us to have a nice Photoshop turnaround time. So we can go ahead and start playing that. Next weekend, just roll that into the asset system so it can just import assets on the fly. All right, that's it. If you want to follow along at home, obviously, as I say all the time, you can always pre-order the game on handmadehero.org. It comes with a source code, so you can play around with it yourself. So yeah, if you want to take a shot at adding hot loading of PNGs before I do next weekend, you could dig out the asset system and give it a shot. All right, until then, have fun programming, everyone. I'll see you on the internet. I'll be back here next week to start rolling that PNG reader into our mainline code. We'll try to do that in a way that allows us to still keep the test cases running. Again, specifically because I don't want to run into a situation where we hit some new bug and we don't have an easy way to debug it. So we'll do that starting next weekend. Hope to see you back here for that. Till then, take it easy, everybody. I'll see you on the internet.